Hi everyone, you are welcome to yet another Mathematics Basic 3 class. Today is a Monday 29th June 2020 and the topic before us is line of symmetry, part 2. We took part 1, that was on Friday when I told you about the meaning of symmetry, the definition of line of symmetry, the difference between symmetry and asymmetry. Then we look at some basic facts. So today we want to take it further. My name is Olusegun Adebanjo and you are welcome to class. We have about 3 learning objectives for today. At the end of the lesson, you say to yourself, I should be able to. The first one, explain the term relational symmetry. Rotational symmetry. Explain the term rotational symmetry. Then the second one, tell what order of rotational symmetry or rotational symmetry order is all about. Tell what order of rotational symmetry or rotational symmetry order is all about. Then the last learning objectives, establish the fact that rotational symmetry order can sometimes help in telling the number of line of symmetry a shape has. Okay, so let's move on. I have about 3 key vocabulary words, even though you are familiar with them, so let's take them again. Symmetry, when you have a shape divided into 2 equal parts and they look alike, so you say that they are symmetry. So when a line, let me take that again. For symmetry, when you divide the shape into 2 equal parts and they look alike, so you will say, we can use the term symmetry. But for line of symmetry, a line of symmetry is a line that divides an object or shape into 2 equal parts. A line of symmetry is a line that divides an object or shape into 2 equal parts, and it is usually in broken form. It is not a solid line, it is not a complete line, it's always in broken form, dotted form. Okay, so and usually it divides shape into 2 equal or more parts. Okay, so when the other part and the half and the other parts look exactly the same, it means the line that divides them, we call it line of symmetry. For symmetrical now, a shape is symmetrical, one half is exactly the same as the other half. Then for mirror image, 2 sides of a shape are mirror images when they are like reflections of each other in a mirror. Okay, 2 sides of a shape are mirror images when they are like reflections of each other in a mirror. Okay, so for learning aid, to explain line of symmetry in regular polygons, below you remember during our study of geometry, we made mention of polygons. Poly means many, gon means side. So shape with many sides. Okay, so below are a selection of common shapes with their lines of symmetry shown as red dashed lines. You can see that equilateral triangle, the square and the rectangle. You can see the line passing through them. For the quadrilateral, the line passes through 3 times. That means that triangle has 3 lines of symmetry. Then for the square, 4 lines of symmetry. For rectangle, 2 lines of symmetry. Okay, so your content 1 here, after you have written your date and your topic, so you have the content 1. The content 2 is still somewhere down in the slide. So this one is explaining rotational symmetry. Rotational symmetry is the act of rotating an object, an image or object, while it will still look the same. Rotational symmetry is the act of rotating an image or object while it will still look the same. That's explaining rotational symmetry. The learning rotational symmetry of common shapes is shown below. You can see the square, the rectangle. What that is saying to us is that if I pick that square now, this is the initial stage as you can see it. So it means I can rotate it how many times and will it still look the same way? Okay, so now for the square, the way it is now, that is the first order. So if I rotate it the other way, does it look the same? Yes, that's second order. If I rotate it another way, does it look the same? Yes, that is third order. Then the last order, that means for square, it has 4 lines of symmetry and it has rotational order of 4. Okay, and for rectangle now, how many times will I rotate and it will look the same way as it is now? So as it is now, that is the first order. If I rotate it the second order, it will not look like this, so you can't count that. Then the third one, it will look like this. So that means for rectangle, it has 2 order of rotational order. Okay, so like that, that's how you check. For the last shape there, which is hexagon, x means 6, gon is side, so 6 sides is in that shape. So it means that that shape can be rotated 6 times and it still look the same. So it means that it has 6 order rotational order. Okay, so let's check the content 2 now. After you have written content 1, so this is the content 2. Order of rotational symmetry a shape has is the number of times the shape can be rotated and still look the same. Okay, so you need to get that right. In case you are not clear about that, you can still ask questions about it. Okay, so for those shapes, if you can rotate them and they still look the same way as they are, so you count the order. That's how to get the order, and sometimes that order determines the line of symmetry. In case you are asked how many line of symmetry does this particular shape has, without rotational order you can easily detect that, and that's what will lead us to this one. Now we want to establish the basic fact that rotational symmetry can help in telling the line of symmetry a shape has. Now the pentagon below can be rotated 5 times and look the same. As you can see down there, pent means 5, gon side, so a shape with 5 sides, a polygon with a 5 side, which is a regular polygon anyway. So this means it has rotational symmetry order 5. You can see the first rotation, second rotation, third rotation. With it is shown with that you can see that red dot. So as you rotate, it still look the same. Okay, so it means that it has rotational symmetry order 5. So it means that we can conclude that some triangles are symmetrical while some are not. It's not all shapes that are symmetrical. This is true of other shapes as well. Not all of them are symmetric. Some are asymmetric. Okay, so the trapezium on the left, you can see those 2 trapezium down the page there. The trapezium on the left has 1 line of symmetry, while trapezium on the right has none. If you look at it, there's no how you can make a line pass through that shape and the other half and the other one will look the same. No, so if that will not happen, then it has no line of symmetry. But for the first one, you can see the line divided into 2. So if you fold that, so it looks the same, like mirror image. So it has 1 line of symmetry because that can only happen if you take it across. Now that's horizontal. The shape at the upper part with the one down will never look the same, so that you can't call that line of symmetry. So for the irregular polygons, many shapes have no lines of symmetry at all, like the triangle shown below. Okay, so you can see you call it it is regular polygon when it has the same length, but it becomes irregular now because the lengths are not the same. Okay, with that, we've come to the end of today's class. Welcome to the end of today's class. Until I come your way again, keep staying at home and keep staying safe. Before I say bye bye, I noticed and I realized it has not been easy for all of us. Let me put it that way. It is, and it's at the same time not good, to keep up with your moral act. When you are online and your teacher is sending his or her greetings, it is always good for you to respond. It's only when you are not online that you are not expected to respond. When you are online, you see your teacher's greeting, please let there be a response, okay? It is good to keep up with your moral acts. For the fact that we are locked down does not mean we will not do the right thing, okay? Then for some of you, check on the stream for your classwork. Make sure you do your classwork. Let it be up to date, okay? Because those things sometimes at the long run will still count either for or against. So I pray it counts for you, okay? For good, all right? So be a good boy and a good girl until I see you some other time. So bye for now. All right.